Okay, here we have CPM Precalculus, Chapter 1, number 41. So here we're given a couple of functions, f of x and g of x. And we're asked to evaluate them at certain regions, or with certain inputs. So part A, we're given g of x minus 2. So when we're given a function with an input other than x, we need to modify what that function is, because we know g of x is square root of x plus 1, but g now of x minus 2, instead of x minus 1, we replace the x with x minus 2, and we still have that plus 1. And then we just simplify this, and we get square root of x, square root of x minus 1, because minus 2 plus 1 becomes minus 1. Okay? We move on to B, f of g of 8. That is basically looking at 2. We want to look at the composite of 1g into f, but first we look at just g of 8. So f stays on the outside while we're looking at g of 8. So I'm going to make big parentheses because we're going to figure out what g of 8 is. G of 8 is, instead of x, we write 8. So it's going to be square root of 8 plus 1. Picking that out straight from g of x, we simplify that, f of square root of 9, that's equal to f of 3. Okay, so then we evaluate f at 3. To do that, we plug in 3 wherever we see x. So we see x squared, so we say 3 squared plus 2 times x, so it's 2 times 3. That's equal to 9 plus 6, which is 15. So that's how we do part B. Okay, part C, we are going to look at, let me create a new page here. Part C, we are just going to look at g of f of 8. So it's just the opposite of what we looked at before. We looked at f of g of 8. Now we're looking at g of f of 8. And this again is part C. So now we're going to do the function of f first. So g stays on the outside, and we're just looking at f of 8. So f of 8, again, is now 8 squared plus 2 times 8, right? G stays on the outside. 8 squared is 64. 2 times 8 is 16. That is going to be g of 80. Okay? Now that we simplified what's on the inside, we can just look at g, and we know it's going to be the square root of x plus 1, but now we have the input as 80, so we replace x with 80. So it's 80 plus 1, square root of 81. We know that is 9. Okay? So these are pretty simple right now. You just gotta know how to follow these different steps. Let's do D. D is asking us f of 1. Okay, we don't even care about g for D. We don't care about g of x at all because we're just looking at the function of f twice. So it might sound confusing or it looks weird because there's 2 f's, but we do what's inside first. Okay, so on the outside we have the f, we keep it there. Okay, so on the inside we have f of 1, so we have 1 squared plus 2 times 1. Okay, simplify that, we have 1 plus 2. Okay, simplify that, we have just f of 3. Now f of 3, we're just evaluating f at x equals to 3. So that's just 3 squared plus 2 times 3. That's 9 plus 6, which is 15. Okay, voila. That's D. So, let me get one more window. E, we're not even looking for a specific value. It's kind of like A. We have f of x plus 1. Again, we don't care about g because we're just looking at function f now. That's equal to, instead of x squared, we have x plus 1 quantity squared plus 2. Instead of x, we have x plus 1. So we always replace what's inside the parentheses with x. Okay, x plus 1 squared you know that that's equal to x plus 1 times x plus 1. You can use the box, x1, right? X squared, x1. And you should get x squared plus 2x plus 1 plus distribute that 2x plus 2. Make sure you remember to keep both of these there. And then we simplify by combining like terms. X squared plus 2x and 2x, 4x plus 1, 2, 3. Okay? And finally f, I'm going to do one more new page. F, we're looking at g of f of x. Okay? Now, this one, again, we start off by looking at the inside. So we have g on the outside. F of x, we just copy in x squared plus 2x because it's just x as the input. Now we plug that into our g of x. We get g of, we don't have g anymore because we're plugging it in. We have square root of something plus 1. So that something now is x squared plus 2x. Okay, so some of you may think, oh, we're done right there, but we're actually not. Okay, you have to look at this now, and can we simplify it any at all? Well, yes, we can. Okay, so this one is an extra special problem. We can factor this, and I know that we can factor in a special way, but you can factor using the diamond method or whatever method you want. We know we want to multiply to get 1, the one here, and we want to add to get 2, right? So what numbers can we add to get 2 and multiply and get 1? Well, 1 and 1. So that's equal to, keep the square root, don't forget that. It's equal to x plus 1 times x plus 1. So that's just factoring what's on the inside there. Okay? Now, here's the tricky part. We have the square root of something squared because x plus 1 times x plus 1 is x plus 1 squared, right? Now, I'm going to change the color. The square root and the squared are opposites. They cancel out. But the thing is, this in here, it can be either x plus 1, or can it be negative x plus 1? So we have to make sure we want the absolute value of x plus 1 when they cancel, to make sure that we're canceling the square root and the squared correctly. Okay? Okay. So this ends chapter 1, number 41 of CPM Precalculus. Oh, forgot to box my answer.